Hi, here we go with some more vector applications. Chapter 8.3, we're going to look at example number 7 from the book. It says, consider an office building whose entrance is 40 centimeters above ground level. All right? Assume an average person, including equipment, is 1,200 newtons. Well, the rest of the story is that you have a person in a wheelchair and disabled and who needs to go up this ramp. And we know that the height from the angle or from the ramp into the building is 40 centimeters. So we have to try and decipher how we're going to use that. And it says that the average person, including the equipment, is 1,200 newtons. So there's a downward force of 1,200 newtons. So let's see, how do we approach that? Well, there's two parts to this. The first part is question A. It says, at what angle would be if a person uses 300 newtons of hand force? So what is the angle if we have 300 newtons of hand force, okay, going up the ramp, but it's 1,200 newtons in the down or against it? So we can use sine here, sine of 300 newtons divided by 1,200 newtons. If I want to find the angle, I take the sine inverse, so sine inverse of 300 divided by 1,200, or the inverse sine of 0.25, will give us an angle of 14.47 degrees. All right? Part B says, well, how long should the ramp be? So we want it to be at a certain angle, and if we know that we have these two distinguishing marks, the 1,200 newtons and the 300 newtons, then what should the distance of the ramp be so to accommodate the downward force and the force that the person is able to give in that situation? So, again, this is where we want to use the 40 centimeters. Had we used the 40 centimeters in this situation, we would not be comparing newtons to newtons. We would be comparing newtons to centimeters, and we don't want to do that. So remember, even though it says in that beginning question, whose entrance is 40 centimeters above the ground, assume this, right? We don't want to compare newtons and centimeters. So, here we are back to this. We've compared newtons to get our 14.47 angle, and now we're going to find the d, or the distance of the ramp. So, sine of 14.47 degrees is opposite over hypotenuse, or 40 over d. It looks like point D, but that's just a chip in my board. So D then rearranged is 40 divided by 14.47 degrees, and that leaves us 160 centimeters long for the ramp. All right? Hope you enjoyed that. Have a great day. Talk to you.